more weeks of Blackboard. I think we can live with it, right? 5 more weeks of Blackboard?
Yeah.
I promise, and I am really, really sorry I put you guys through it. I really am. I thought it was going to be much better than it is. I think it works great for 75% of students. I think it's pissing 25% of you off. And I apologize, because you 25% are 100% pissed. And I do apologize for that, because I don't want it to get in the way of the learning of statistics, which I think it is doing. I forgot to bring a little green table over here. Oh, I left them over here. Thank you, Lloyd. Much, much appreciated. Okay, so we were smack dab in the middle last time of discussing a wonderful topic called relative position.
Right.
Tell me anything you remember about it. Anything that you remember about it. If that's nothing, that's totally fine.
The percentiles.
Percentiles! Tell me about those. Tell me what you remember about percent. That's one way of measuring relative position. What was the idea of percentiles? Max in his 85th percentile head girth. Or his 90th percentile length, or his 80th percentile weight.
He's that percentage above the rest.
Boom! Or he's, can I take two of those words and move them, Kelly?
Yeah.
He's that percentage, he's above that percentage of the rest. I just took your 80 and above it, and that's okay. I think you meant the same thing. So if Max is in the 80th percentile for something, that means he is fattier than 80% of whatever we're measuring. 80% for weight, he's heavier than 80%. 90th percent for length, he's lengthier than 90%. 85th% for head girth, he's girthier than 85%. So it's just a cutoff. This many below, this many above. Well, actually, it's just this many below. This many above comes for free afterwards. Good. Excellent. Percentile, very general, very straightforward. I think we ended last time by doing the percentiles of our state visits. We're going to come back to that data momentarily. Good, 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 good. Anything else from last time? Percentile. That was a big chunk we did last time. Anything else you remember?
Quartiles.
Quartiles, Kevin. What were those?
Q1 is like 25% of the way, and what is that, Q3, right?
Uh-huh.
75%.
Nice. Oops. P75. So, a Q1, the first quartile or the lower quartile, is another word for the 25th percentile. Now, why do they call it two different things? Convention. Woo. Convention. There's also deciles. There's also octals. I mean, there's many ways to break up 100%. For some reason, quartiles and deciles. Have you ever seen the decile comparison of American income or American wealth broken up by deciles or by quintiles? By 20% of the time, 20, 40, 60. Anybody ever seen that one? The quintiles of American wealth? Oh, make a quiz out of that one. That's a good one. That's actually, it's a good one, and it's like, holy crap. Pareto was right. Gesundheit. Hang on one second. Let me just send this email to myself. That'll be a good quiz for you guys, especially seeing how it all ties to deciles of wealth. All right, good. We'll have that up for next week. Anyway, quartiles. What? We skipped Q2. Because that's the median. It's not usually called Q2. It's usually called the median. Yes. It's usually called the median. It is Q2, because that's the 50th percentile. It's the divider of the top and bottom half of the data. It's the division of that. Good. There's also conversationally a Q0 and a Q4. Conversationally, much as exactly, thank you, Anna, this is your minimum value, and here's your maximum value. They're conversationally called that. Mathematically, they don't really exist, but you can conversationally call them that. It's no problem. Also, the 0th percentile and the 100th percentile. Basically, if you're the 0th percentile, you're the smallest data point of whatever you're measuring. And if you're the 100th percentile, you're the biggest data point of whatever you're measuring. So we discussed why you can't actually be either one of those in reality, but nonetheless, it's conversationally used. And we also discussed why very often, especially in small data sets, you might not land exactly at 25% above or below. Because if you say have, for example, something like 41 data points, it's going to be hard to chop exactly 25% and 75%. It's not going to mathematically work out. With larger data sets, it works out just fine. And with smaller data sets, it averages just fine. Whole law of large numbers argument again. Good. Did we crank these numbers for our snowfall data? Do you remember? I don't remember. We didn't?
No.
Beautiful. Do you still have the snowfall data in your TIs? You might not. That's okay if you don't. I saved it. If you don't. I said snowfall. I meant state visits. Sorry, we haven't got the snowfall yet. We're doing snowfall next. I'm sorry. State visits. Snowfall's for a quiz in class. Get sidetracked. Some of you guys did the snowfall quiz from last week. I got all these data sets floating around in my head. Okay. Let me get in here. You guys, I believe, 6, 6, 7, 7, 8, 9, 9. Does that sound like you?
Yes.
Yeah.
Good, excellent. All right, I'm gonna go ahead and bring that over to L1. There you go. I sorted mine. Did we talk about how to sort data last time? Comes in handy sometimes. I think we did that because we were having you guys find your percentiles, and it made it easier to see when they were in order. Yeah.
Yeah, mine are in order.
Excellent. I thought that was like one of the last things we did. Beautiful. Now, all you gotta do is run.
7, 8, 9, 9.
Run your. Are we agreed? 6, 6, 7, 7, 8, 9, 9. That keeps going.
Yeah.
There we go.
Yeah.
Beautiful, beautiful. All you got to do to get these 5 numbers right here is just run one of our stats and arrow down. And I'm going to say it again, Andrea, because I love the whole L1, L2 versus not using that. When you have raw data, it's as simple as grabbing one of our stats and pressing F. Whoops. Except when you have plots turned on. Hang on. Or a decimal point in front of it. Go to delete. One of our stats, press enter, boom, everything falls out. No frequencies. Everything's got a frequency of 1 now. Cool! So we get an average of 15 and a third states per person. We get a 7 point, that's about an 8, standard deviation of 8. What made us a little bit concerned about using the average as far as discussing states? What made us a little bit wary of that? Do you remember?
Oh, we were kind of skewed, right?
Right, but this is why, back to our discussion. Andrea's looked at the variation quiz for this week where we talk about how to measure skew. Right, when you look at something, you go, that's not quite a bell curve. What does quite a bell curve mean? Well, let's take a look at it, yes? Let's draw a graph. I think we did that last time too. Let's get that back up on the screen. I'm going to turn you off for now, but I'm going to turn you on. That looks pretty good, right? On, histogram, L1, frequency 1, golden, zoom 9. Okay, it looks like a dinosaur with a tail. Dimetrodon to be exact. Right, maybe partial stegosaur. But definitely not a bell curve, at least not bell in for me. Can we refine the curve and make it not quite so bar? Can we make the bars smaller? Do you remember how to do that? Remember how to get in there and finagle with the bars? I know it's been a long weekend. I apologize for asking all these questions first thing in the morning. It's terrible. What button do you push? Do you remember?
Window.
Window! Thank you, Gail. Window, what do you mess with?
Scales.
Actually, it's a pretty nice number. It's 5, which is, I don't know, like 6.2 or something silly like that. Change it to 3, just for an illustration. And then just press graph. When you press graph, there it is. So now it looks like a dinosaur with the fin shot off, but it's still got the skew to it, right? It's still got that skewiness to it. Right, skewiness, that's good. That's a new word, skewiness. The cookie. And you can mess with it even more. There is a limit to what you can mess with. If you make the scale too small, it's going to get, well, actually did it for me. Sometimes it won't do that with 1. I thought it was going to give me an error. There are times when you get an error stat when you make the X scale too small. Apparently that's not too small. So just so you know, that's what's called a dot plot. That means you've actually got a width of 1. 5 states, 6 states, 7 states, or for you guys it's 6 states, 7 states, 8, 9, 10, 11, 12. So this is actually a dot plot, which is kind of fun. Usually you can't do those. I don't know why you can now. But no matter how you look at it, it still looks skewed to me. It still looks skewed. I like the 3. The 3 was kind of a nice look. Now some of you are going to say, that's bell-shaped enough. We can calculate the whole skew coefficient if you want. Matter of fact, I'm going to do it real quick. You guys don't worry about this. I'm just going to get the skew coefficient. It was average. Andrew, help me. Andrew, it's average minus median, right? Divided by standard deviation. All right, let's just do that. Statistics EQ. Where's the median? I think it's here. Median all over the standard deviation. There's the skew, 0.17, which, if you didn't look at the quiz for this week, I'm not going to mean a damn thing to you, and that's okay. But if you did look at the quiz for this week, that falls into a range of skewiness. 0 is no skew at all. And as you get further from zero, this is right skewed, which means the average is floating out to the right. Further from 0, the more skewiness. And Hildebrand gave us a little laundry list of numbers to operate off of, if it's between 0.1 and 0.2 and blah, blah, and I can't remember them all. I look at it and I go, I don't think it's a bell curve. I think it's a non-bell curve. So I'm going to talk about something else besides average. My opinion. Doesn't have to be your opinion. Fair? Okay. What I want to focus on really though, whoops, are these 5 numbers down here. These are the same 5 numbers we just talked about over here. They're fairly important in statistics. They're called the 5-number summary. They're called the 5-number summary. Kind of a fun, it's a fun idea. They get used quite